Hello everyone. Today I am going to discuss the last problem of biweekly contest 134 Leetcode, which is number of Subarrays with n value of k. So the problem title itself explains the problem statement. So we have given some integer array nums and an integer k. We have to find the number of Subarrays nums where the bitwise n of all the elements of the subarray equals to k. If we take the first example, here 1 1 1 and the bitwise k value is 1. So if we take any subarray of the given array, there are total 6 subarray of the given array is possible, and each subarray will have bitwise n value equals to 1. So the answer will be 6. Now let's take the second example and try to understand. Let's say the example is 1 1 2 and k value is equals to 1, k equals to 1. So let's the subarrays are nothing but the first subarray is 1, second subarray is 1, third subarray is 2, fourth subarray is 1 comma 1, and fifth subarray is 1 comma 2, and the last subarray is 1 comma 1 comma 2. Okay, so what is the bitwise end of the first subarray? The bitwise end of the first subarray is 1, second subarray is 1, third subarray is 2, this is 1, this is 0, and this is 0. Now what are the number of subarrays whose bitwise end is equals to k, which is 1? So this is, so the answer is 3. I think the answer is 3. Yeah, the answer is 3 yet. Now you can take the last example and try it yourself. The answer should be 2. Now, how we are going to solve this problem? So, first of all, let's discuss about the possible time complexities for the solution. So, here n value is around 10 to the power 5. N value is around 10 to the power 5. So, overall time complexity could be order of n, and the value of k and num size is around 10 to the power 9. So overall time complexity could be order of n or order of n log k. Okay, now I am going to solve this problem in order of n log k. Now there are some properties of bitwise n we are going to use. Let's say we have some subarray from L to R which is equals to k. Okay, then we can say that if L to R plus 1, let's say L to R plus 1 is not equals to k, then after L to R plus 1, let's say we take L to R plus 2, this will never be equals to k. Why? We can say that if bitwise n between L to R should be always greater than equals to bitwise n of L to R plus 1, and this should be greater than equals to bitwise n of L to R plus 2. I hope you get it. Now if this value is not equals to k, that means this is less than k, and that means that L to R plus 2 should also be less than k. So let's say for how we are going to solve this, we are going to find for every value I, for every index I, we will try to find L and R value such that L and R value such that from the I to L is a valid subarray, I to L plus 1 is a valid subarray, and still I to R is a valid subarray. So the overall answer, our answer will be nothing but R minus L plus 1. There are R minus L plus 1 subarrays from starting from I containing index I, whose bitwise n value is equals to k. Okay, so we'll add R minus L plus 1 contribution to our answer. So for every index I, we will try to find out the possible subarrays starting from index I, which this bitwise n value is equals to k by this approach. So for every index I, we have to find this L and R value. Now how we are going to find this L and R value is the problem. So let's take one example. Let's say our example is, let's say example array is 7 3 1 1 and 2, and let's say our bitwise n value k value is equals to 1. Now let's say our I value is 7. Now you can see that the possible answers are nothing but 7 3 1, and another answer is 7 3 1 1. Now the L value here for let's say we are finding for I equals to 0, the L value here is nothing but 2, and R value is nothing but 3. Now how we are going to find this L and R value here? Now we have only 3 bits, so let's talk about 3 bits only. So there are 3 bits, sorry, 4 bits, 0 1 2 2 to the power 0, 2 to the power 1, and 2 to the power 3. So we have only 3 bits, 0 1 and 2. Now the zeroth bit is not set in which indexes. Zeroth bit is set in the 0th index. So we'll create one array or vector for each indexes where the bit is not set. So 0th bit is not set in which indexes? zeroth bit is not set in 0 1 2 3 fourth index. Now first bit is not set in which index? First bit is not set in second index, third index, okay. And second bit is not set in which index? Second bit is not set in 2 to the power 0, 2 to the power 1. Second bit is not set in this index, 1 2 3 and 4. Yeah, 1 2 3 and 4. Now how we are finding L and R value? Our L value will be the maximum value. Let's say some bit k, let's say some bit I is set in our k. So which bits are set in k? Only 0th bit is set in k. So we'll try to find out what is the uh, so from from I to L, sorry, from I to R, all the indexes should have this bit set. So from I to R, every index should have the this bit set. So we'll take the minimum value as 4. Okay, so R value, yeah, R value will be 4 minus 1, which is 3. Okay, now L value will be the minimum of these indexes where this bit is not set. Okay, so the index will be 2. Okay, so L value is 2 and R value is 3. So you understood it, right? How we are finding the L and R values? So L value is nothing but the indexes, the maximum index such that the bit is not set in k. Maximum index such that the bit is not set in k. Okay. So the first bit is not set in 2 and the second bit is not set in 1. So we have to take this index. We have to take this index 2. Okay. Because if we don't take this index, if we take L values which is less than 2, the bit j value, bit of 1 value will be set. Similarly, the R value is 4. If we take anything greater than 4, okay, if we take the value 5, then 0th bit will not be set. Okay, 0, sorry, if we take anything R value which is greater than equals to 3, sorry, greater than 3, if we take the R value as 4, then the bit 0th bit will not be set in 4. Okay, so let's jump into the code. You will understand it better. So I am taking one q. I am taking dq here, but q will also solve our purpose. But we as q dot clear function is not available in C++, that's why I thought about using dq. The same function functionality is available in dq also. So in the indices dq or indices q, I am pushing all the indexes where bit I is not set. So I am checking if the num size value has this bit jth bit is not set, then I am pushing the ith index in the jth bit indices. Okay, now bit size will be 1, that means the bit is set in k, and if it is 0, then that means the bit is not set in 0. This is not needed. You can use this condition here also, but I for more readability I have used this bits I. Okay, now for so I am adding L at the end of every indices. Okay, so this is for some kind of ease of the code I am doing this. If we are not doing this, then we have to do some kind of more handling. You will understand when we are reading this part. Okay, now we are taking mini means our R and maxi means our L, because we will take for L we are taking the max values, and for R we are taking the min values. That's why I have named L as maxi and R as mini. Okay, so if bit j is set, okay, if bit j is set, we are setting uh, uh, R value as minimum of R mini, comma, the front value of the indices. Okay, the front value of the queue. And if the bit j is not set, we are taking L as maximum of L, comma, front value of indices of j. Now, so how these indices will help us? So when we are at index I, we'll pop all the elements which are less than equals to current index from all bits. Okay, indices. So if the indices j dot front equals to I, we are popping the front element from the indices j. Okay, and so this means this step means that the front value of every indices j should be greater than equals to k. So if we are not doing this step, we have to take some kind of lower bound. This is also possible, but this will add some kind of log n time complexity to our code. So our overall time complexity would be in log k log n. So we, for avoiding that, we are doing this kind of approach. And after this is over, we are adding answer plus equals to mini minus maxi, because if we are not doing that, we have to decrement the value of r like this, and we have to take r minus l plus 1. So our maxi value is nothing but r plus 1. That's why we are doing adding r plus 1 and deleting minus maxi from here. Okay, I hope you get it. I hope you get the solution. I'll provide the link of the code in the description box. If you have any doubt in any part of the code or explanation, you can always ask in the comment section. I'll try to reply each and every comment. If you find this video helpful, please like the video and subscribe to the channel, and also share among your peers. Thank you.